All right, now considering this this math section, we're looking at all of the things on your worksheet. So last time we did a video here, it was more focused on things that just needed more help with, like more attention to. This is more broad, so instead of doing just problems that that you need more attention on, we're doing all of them, and that's okay. But that means I'm going to spend less time per one so that this video can get to you before, you know, a 13-hour upload, right? Because the longer the video, the more intense it is in terms of length of time it takes for it to get onto YouTube. So I'm going to kind of blitz through these. Feel free to play and pause as needed. And let's begin. So this is section 8.6, and it talks about rational exponents. So let's start with number 1. And just for a brief second, here are the concepts that we're going to be exploring here. Anytime you see a fraction as an exponent, you use two parts of the fraction, the top or the bottom. So the bottom piece is going to be whatever the radical is. So this is going to be the cube root of 8, because the bottom piece is a 3, and the 1 is essentially just saying this whole thing would be to the 1 power, which is the same thing as itself. Okay. Now, when we get to something like, and that's the answer number 1, by the way. Number 2, when we get something like number 2, 9 and 3/2, or 9 to the 3/2, it's going to be the cube. It's going to be the square root of 9 cubed. So that can definitely be simplified, because we have the square root of 9 is plus or minus 3, and then you just cube that, and you get two answers. You get negative 27, and you get positive 27. And so your answer is actually plus or minus 27 on that one. Okay, but that's how we're gonna be working these from here on out. So give me just a second here. Right on. So that's that. All right, cool. So, and just a quick recap how we got here. If you notice here, I said plus or minus 27. It's because the square root of 9 is positive 3, and the square root of 9 is also negative 3, because negative 3 squared is 9. 3 squared is 9. And so when you take the square root of 9, you're going to get two answers, plus or minus. And this is going to be true anytime you take a square root of anything. There's always the positive answer and then the negative answer. How curious, life also works similarly. Everything has a positive outlook and a negative outlook. And the choice is yours. All right, now, let's see. 25 and 3/2. So this is going to be the same thing, right? The bottom, this is what I'm looking at, the bottom is a 2. So I'm going to do the square root of 25. I don't have to put a little 2 there. You can, but when you do a square root, it's already understood that that's, you know, square root 2. And then this whole thing is cubed, and I know that by the top number. And so the square root of 25 is plus or minus 5. That's cubed. Therefore, my final answer is plus or minus 125. Ta-da. Teacher might prefer it to be one answer, but she can't do that because that would be wrong, no matter how you cut it. So you should have two answers for this. If she wants to debate you, you actually have grounds to stand on. All right, negative 8 to the 1/3. All right, cool. So again, I'm just going to look at the bottom number. So it's the cube root of 8, and all that's to the first power. That's going to be 2. Because, and let me put it down here in parentheses, 2 times 2 times 2 would equal 8. That's how I got that. 5 negative 25 to the 1/2. All right, so now we have square root of negative 25. To know if you guys have actually gone over complex numbers, I don't see that one here, so I'm not going there. Just for now, all you need to know is with rational numbers, you cannot take the square root of a negative number. So I'm going to leave this alone. If you guys are using complex numbers and you know what an imaginary number is, let me know, because technically this answer is 5i. But we're not going there. Just for now, it's impossible, quote, quote, to take the square root of a negative number. Ignore it for now. All right. 25 over 49 to the 1/2. When I see something like that, it looks bad on the surface, but it's not. You're just taking the square root of each part. Square root 25 over 49. Square root of 25 is plus or minus 5. Square root of 49 is plus or minus 7. So your actual answer is plus or minus 5/7, because it could be negative 5/7 or it could be positive 5/7. It doesn't matter. They both take you the same place when you square it. Number 7. 125 to the 2/3. Looking at my bottom number here first. So the cube root of 125 is going to be, oh sorry, and then you do that squared. That's going to be 5 squared, which is 25. 8. A to the 3/7. I don't really know what she's wanting here. It says rewrite it in radical notation and simplify, so I assume you just need to rewrite it in radical notation. So looking at the bottom number, the 7th root of a cubed. This is your answer. Nine. A to the 7/3. Same deal. Cube root of a to the 7th. Done. Now that I'm looking at it, nah, I'm not gonna mess with that. Go ahead, but you may want to ask her for further clarification if she's wanting more than that, because I think I see one way it could be maybe simpler, but I'm not going there. A to the 5th, B to the 3rd to the 1/2. Let's see, 1, since negative powers. All right, when you have a negative fraction as an exponent, all that means is in the wrong place. So, and I think we sort of talked about this before, right? Let's explore that concept real quick. Remember when we had a to the negative 3rd, what that really meant is just 1 over a to the 3rd. It just meant that the 3 needed to be on the bottom instead of the top. That's why I said negative 3rd. So it's the same deal here. 9 to the negative 1/2 really just means it's 1 over 9 to the 1/2, which is 1 over the square root of 9, which is 1 over plus or minus 3. So that's, you know, plus or minus 1/3 is the answer to this. But see how we got there, right? We go, it's in the wrong place. Put it in the right place, then work it like normal. Square root of 9, Ta-da, square root of 9 is plus or minus 3. Cool. 1 over plus or minus 3 is the same thing as plus or minus 1/3. Cool. And done. Next. Same thing here. Just going to translate it to what it means. Then put it into a form that they want it in. Then take it on down. Now, if you're wondering why we don't have a plus or minus here with this cube root, it's because, remember, when you're cubing something, it retains its symbol. So all that means is if you have -1 times 1, if you have -1 times -1 times -1, the final answer is still -1, right? Because these two right here turn into +1. But then it still times a -1, so it goes right back to where it started. Got it? And so, in terms of a sign. And so, when you're cube rooting things, it's going to retain its original sign. When you square root things, there's always two possibilities, right? Because if you have 1 times 1, that is +1. If you have -1 times -1, that is also +1. That's why we always have two answers for a square root, but a cube root will have a single answer. And this is going to be true of 5th roots and 7th roots and so on and so forth. If it's an even number, it's going to have two answers. If it's an odd number, it's going to have one, in terms of the sign, at least. Alright, number 3, 27 and -2/3. So that leaves you with 1 over 27 to the 2/3. And now let's translate this. 1 over the cube root of 27 squared. Cool. What's the cube root of 27? 3. 1 over 3 squared. Cool. And what is 3 squared? 1 over 9. Done. Not bad at all. Just the thing with this is just taking it one step at a time, which if you really pay attention, in higher math, that's the... In higher math, that's the curveball. That is your best friend always. It's taking things one step at a time, not trying to see too far ahead. So 1 over 64 to the 1/3. 1 over the cube root of 64. Cube root of 64 is 4. Ta-da. And you're done. Not bad at all. Just take it one step at a time. What do you have in front of you? Focus on what you got in front of you, and then move to the next step and focus what you got in front of you then. Now, this is a curious one. You got 1 over 25, and all that's to the -1/2, right? So remember, when we see an exponent, that means this, whatever's in front of it, when we see a negative exponent, whatever's in front of it's in the wrong place. So, if this right here is in the wrong place because it's got a negative exponent, that must mean that this whole thing needs to be flipped, right? This 25 needs to be on top. So, I'm going to do that. 25 over 1 to the +1/2, right? So 25 to the 1/2, and 25 to the 1/2 translates to the square root of 25, which translates to plus or minus 5. Cool. Again, just paying attention to when you have negative exponents, it just means everybody's in the wrong spot. Put them in the right spot. Alright, same deal here. Flip it upside down. Everybody's in the wrong spot. Cool. Now, cube root 27 over 8 squared, which translates into, what's the cube root of 27? 3. What's the cube root of 8? 2. Cool. And square it? Cool. And final answer? 9/4. Easy peasy lemon squeezy. Alright, I'm going to leave the you tries for you. Alrighty. On to our next section. Square root of 3 times the square root of 2. So in this whole section, we're just multiplying radicals. This is okay. Just multiply numbers underneath, and the radicals, if you have two radicals, they just cancel each other out. So here we go. Or sorry, that's not true. Ignore that last part where it said they cancel each other out. That's not true at all. Just bring it over with them. All right, square root of 6 is your answer here. Easy enough here. Square root of 3 times the square root of 3 equals square root of 9, which is 3. Plus or minus 3. Square root of 5 times the square root of 15 equals the square root of 75. Now with something like this, keep an eye on it. This can be simplified, and here's what that means. The square root of 25 can be broken down into 25 times 3, right? So the square root of 25 times 3 is the same thing as the square root of 75, right? Well, the 25 can be square rooted. That's a perfect square. So the square root of 25 is plus or minus 5. Square root of 3 has to stay inside though, because we don't have that's not a perfect square. So this would be square root of 5 times the square root of 3. That's your final answer here. Because again, what I did is I took 75, broke it down to 25 times 3, took the square root of 25, which is 5, and put it outside of the radical because it's already been square rooted. Square root of 3 has to stay inside because it has not been square rooted yet. So that your final answer is plus or minus 5 times the square root of 3. Easy. Number 4, square root of 3x times the square root of 6x equals the square root of 18x squared. There is some stuff in here that can be simplified out because there's some stuff that can be square rooted. So this can be broken down into the square root of 9 times 2 times x squared. The square root of 9 does have a perfect square. It is plus or minus 3. And the square root of x does have a perfect square, which is x. 2 has to stay inside. Plus or minus the square root, or sorry, plus or minus 3x times the square root of 2 is your answer. Two times the square root of 7x times 3 times the square root of 14x. Alright, same deal here. Just multiply across to start off with 98x squared. Does that have a perfect square? Is the question I'm asking myself. So I'm going through a list of perfect squares in my head to see if there's any spot that they meet at. I see 49 in my head. So 6 times the square root of 49 times 2 times x squared. Square root of 49 is what? 7. So 6 times 7 times, and the square root of x squared, you know, is x. You leave the 2 inside. And you know this whole thing's plus or minus. We've already discussed why. So plus or minus the square 42x times the square root of 2 is your answer. 6. Cube root of 25 times the cube root of 5. Cool. Cube root of 125. And you can cube root 125. Actually, it turns into 5. Done. Next. 3 times the cube root of 18x times 2 times the cube root of 3x. 6 times the cube root of 54x squared. Alright, we know we can't cube root the x squared, so we're going to leave that alone. Can you cube root the 54 is the question. And so going through the mind's eye and looking for, or is there anything inside of 54 that could be cube rooted? And I know 27 can right off the bat. So 6 times cube root, so 27 times 2 equals 54 times x squared. You can take the cube root of 27, it's 3. So 6 times 3 times 2x squared, cube root of those things. 18 on the cube root of 2x squared is your answer. Alright, number 8, cube root of 36x times cube root of 15x squared That's a big old number. Let's get out a calculator and see what 36 times 5 is. Sorry, 36 times 15. 540 x cubed. All right. Okay. So, is there any number that can be cube rooted out of that 540? That's the question. Good God. Just looking at it, I know that you can do the cube root of 27. So you can do the cube root of 27 times 20 times x cubed. And we know that x cubed is going to cube root out to be x. And we know that 27 is going to cube root out to be 3. So that leaves 20 inside. And then are there any multiples out of 20 that could be cube rooted? And I'm not seeing any in my head. Because 20 is what? 10 times 2. Can't do anything with either of those. It's 20 times 1. Can't do anything with either of those. It's 4 times 5. You can't do anything with either of those. And you're done. So this answer is finished. That looked tricky because it was a little bit, but not bad at all if you just know the rules. Math is all about knowing the rules. Once you know the rules, you can bend them however you see fit. All right. That was it for that section, leaving the you try for you. All right, combinations. All right, here we go. Number 1. Square root of 3 times 1 plus the square root of 2. So the square root of 3 plus the square root of 6. And that's all you're going to be doing with that. Yeah, that's all you're going to be doing with that. You're not adding those because they're not like these numbers aren't the same, so you're not going to be adding them. So yeah, let me I'm gonna check here. Gonna make sure that's all you're gonna do there. It seems like that's a little simple, but let me check. What I'm doing right now is I'm just punching in a calculator. What happens, punching in the square root of 3 and adding it to the square root of 6, I get 4.18. And I know it's not the same as square root of 9, which is 3. So yeah, I'm right. You cannot add these up because you can't add them up. So you're done. That's it for number 1. That was pretty easy. I was like, this is a little easy. I don't know about this. No, yeah, you do. It's okay. All right, square root of 2 times 2 minus 3 on the square root of 2. All right, cool. I'm going to distribute. So I got 2 on the square root of 2 minus 3 times the square root of 2 times the square root of 2. Oh! So the square root of 2 times square root of 2 is going to give the square root of 4. Square root of 4 is 2. Aha! So 2 on the square root of 2 minus 3 times the square root of 4, which is 2. Or plus or minus 2, rather. So you get 2 on the square root of 2 plus or minus 6. That's the correct answer. She might just want to go with minus 6 and assume this is positive, but you can't assume that because it could be positive or negative. Didn't know how your teacher wanted to do it, but if she's trying to do math, you sort of have to follow the rules. All right, square root of 3 times 4 plus the square root of 6. 4 times the square root of 3 plus the square root of 6 times 3. 4 times the square root of 3 plus the square root of 18. Square root of 18 can be broken down into 9 times 2. Square root of 3. Oh wait, did I just drop off my 4? I did. This is why it pays to write out every step, because I looked up, I'm like, wait, where'd my 4 go? It disappeared. plus 3 times the square root of 2, because we know the square root of 9. And remember, this is plus or minus 3 times the square root of 2. And that's finished. And again, you might want to ask her if she wants you to do the plus or minus thing. I was always taught to do it in that form, and I was told why as well. Because it's true. You can't take the square root of anything and not end up with 2 answers. All square roots have 2 potential answers. She may not care for you to write down the second answer, IDK, but I would check with her to see what she wants you to do there. 2 times the square root of 3 times 5 minus 3 times the square root of 10 times 5. All I did was distribute this. 2 times the square root of 15 minus 3 times the square root of 50. Is there anything that can be brought out of these guys right here? That's what I'm looking at. I'm looking for perfect squares. I do see one over here. It's 25 and 2. So 2 times the square root of 15 minus 3 times the square root of 25 times 2. And 2 times the square root of 15 minus 3 times 5, because the square root of 25 is 5. And I'll leave the 2 under there, so that I would get 2 times the square root of 15 plus or minus 15 times the square root of 2, because that's 3 times 5. And I did plus or minus because, remember, it's a square root. It's got 2 answers. And ta-da, you got it. All right, number 5. And I think going forward, we probably need to do just things you have a question about, because I think this video is probably going to be close to an hour long, which may be a little heavy. All right, 4. All right, here's number 5. 4 plus the square root of 3 times 5 minus 2 times the square root of 3. 20 minus 8 times the square root of 3 plus 5 times the square root of 3 minus 2 times the square root of 3 times the square root of 3. Alright, so this is 20 minus 3 times the square root of 3, because I can actually do something with these guys. They have the same radical, so I can add and subtract them just fine. And then this is minus 2 times the square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is plus or minus 3. So, yeah, for this you'd have to pick one, right? You'd have to pick one and say, am I going to do positive 3 or negative 3 for this? I'm going to pick positive 3. It's easier. But just keep in mind it should be plus or minus. So 20 minus 3 times the square root of 3 minus 6. So 14 minus 3 times the square root of 3 is your answer, even though technically it could be 26 as well, because if you went negative. But we'll leave that alone for now. Alright, number 6. 3 minus the square root of 2 times 3 plus the square root of 2. Alright, this is I'm just using FOIL. It's gonna be 9 plus 3 times the square root of 2 minus 3 times the square root of 2 minus the square root of 2 times the square root of 2. Alright, and so these guys are gonna cancel each other out. Positive 3 on the square root of 2 minus 3 square root of 2. That's gonna cancel out because it equals 0. And so you're left with 9 minus the square root of root 2 times square root of 2, which is square root of 4. You get 9 plus or minus 2, which means your answer should be either 11 or /and 7. Pick one. It's legitimately both. The answer she'll probably give is 7, because that's what happens if you assume it's positive 2. But you'll learn this coming up real soon. All of these squared functions are called quadratic functions, and they all have 2 answers. Because when you start graphing them, you'll see that your graph crosses the x-axis at 2 points every time. And that's because you have 2 answers every time you do a square root. Because when you square something, it always nullifies the sign to positive. Alright. All right, I'm gonna go ahead and upload this first part. I need to be smart here. I'm gonna upload this first part, and then ask for further guidance on how you want the rest of this. Okay.